So welcome to the continuation of module for Java programming for the course AC312. So we are having our fourth lecture. We'll be talking about classes, objects and methods in this lecture. So classes, as the name indicates, provides a method for packing together a group of logically related data items and functions that work on them. So data items in a class is called as fields and the functions is called as a method. So once a class type is created, then we can define variable of this type, and these variables are called as objects. So you are having a class is kind of where you are packing both the data and the functions, and the variable that you declare for a class is called as an object. So syntax for a class is you have the keyword class space class name, and then there is an optional field which says extends super class name. So this comes if you are inheriting this class from a different class. Inside the class, then you can have a field declaration and the method declaration. So whatever is there in the square bracket is optional. So you can either have only field declaration, you can have either only method declaration, you can have both of them together, or you can have none of them. So this is basically class. Now let's look into each of these members inside the class. First is called as a field. So data is encapsulated in a class by placing data fields inside the body of class definition. So you have a class inside which you are declaring some data. You are declaring a variable to hold some data. So these variables are called as instance variable, as they are created only when the object of the class is instantiated. So when you create an object, then only these variables are created in the memory. So when you declare a class without creating an object, it doesn't allocate a memory in the RAM. But when you declare an object of this class, then the required amount of memory will be allocated. So this is an example where you have two field definitions, two member variables. One is called as length, one is called as width. Both are of type integer. So int means like the length will get allocated 32-bit memory, width will also get allocated 32-bit memory, and these two will be allocated only when you declare the object. So methods are like functions, or they're exactly functions, but it is defined inside the body of the class. And methods are used to manipulate the data inside the class. So if you continue with the previous example of rectangle, so you already have the member variables or fields, which is length and width. Then you have defined a function inside the class, that is void get data index comma int y. So and inside the function you are just copying the value of the parameters to each of the member data members, that is x is copied to length, y is copied to width, and this function is called as a method. So the method name is get data. The method is not returning any kind of data because of which it is void. Method is accepting two input parameters x and y, and both are of type data type integer. So here's an example for you. So there is a class being defined here, and there are some method. There is a method and a field or a data member being declared. So you want to find what is the name of the class, what are the fields and methods inside the following class, what is the return type, method name, and input parameters of the method. So if you look at this, you need to find out what are all these class, methods, return type, method name, and input parameters. Now let's move forward. So let's say you are going to create an object. So an object in Java is essentially a block of memory that contains space to store all the instance variable. So when you create an object, whatever is declared inside the class will be allocated a memory, or you can say a block of memory in which they can be stored. So creating an object is also referred to as instantiating an object. So when you say create an object, it is equivalent to saying instantiating. And objects in Java are created using new operator. The new operator creates an object of class and returns a reference to that object. So if you take this example, rectangle rect1, so this doesn't create an object, it only declare a variable rect1, and it will not be allocated a memory, just says that you are declaring a variable rect1. Now, so when is the object created? So when you assign this variable rect1 using new rectangle, so when you say new, it means you are going to create a new memory location of type rectangle, and the reference of that memory location is passed to the rect1 variable. So this is where the actual object is being created. So in the previous example, in the previous slide, we have seen that you have done this instantiation or creating an object in 2 steps. Basically you can do it in a single step, where you say rectangle rect1 is equal to new rectangle. So both are same. So this will both are same, except that you are creating the object in 2 steps here, while you are creating object in a single step here. So you can create any number of objects for the same class. So in this example, if you see rect1, you are creating a new object, rect2, you are creating another object, and these 2 objects are totally different. So these are 2 different memory locations, and the variables or the methods and data members of both of them are different. Although they have the same name, they allocate different memory locations, because of which when you access these members, they will be different. So each object has its own copy of instance variable of its class. That is, any changes to the variables of one object have no effect on variables of other. So if you look at this block diagram, so there is a memory location of rectangle, it has its variables, methods, etc. here. This rect1 object is pointing to that memory location. There's a totally different memory location, but of the same type rectangle. Again, it has variables and methods inside this one. Rect2 is pointing to this memory location. So these 2 memory locations are totally different. So whenever you access the variables and methods using rect1, that is totally different from rect2. But let's say you want to have both these objects pointing to same memory location. Still you can do that. So you can declare the first object as r1, and it is created a new memory location, or it is instantiated as new rectangle 1. You create a different variable r2, and you just say r2 equal to r1, which means the r1 and r2 are pointing to the same memory location rectangle. So whatever variables or methods in r1 is equivalent to the variables and methods in r2, and if you change anything using r1, it will get reflected in r2. Now let's say how we can access the class members. So we have the class member as, we have variables and methods as class members. So we need to access each of them outside the class. How will you access it? So syntax is, you create an object of the class, you say object name dot variable name, and you assign a value. So if it is a variable, you can assign the value using dot operator. Object name dot method name, and if you have parameter in that method, you just pass the parameters, it will be passed. So example for accessing the variable is like this. So in the previous example, we have seen rect1 is an object being created, length and width are 2 members of the class, which are variables. So you can say rect1 dot length equal to 15 and rect1 dot width equal to 10. So basically you are assigning a value 10 to width, 15 to length. Now rect2 is a different object. So rect2 dot length equal to 20, rect2 dot width equal to 12 will assign a value 12 to width and 20 to length. So you should note that rect1 and rect2 are 2 different objects, which means the length and width of each of these objects are different, and they will get different value get assigned. So we look at an elaborate example. So this is a basically an example where you have the class rectangle, you have 2 variables are declared, length and width, member variables. You have methods get data and rectangle area. So rect area will calculate the area of the rectangle and return the area. You have declared in a different class the void main function, and you are doing many things inside the main function. So let's go step by step. So initially you have declared the variables length and width, You have declared the methods inside the class rectangle. One is get data with input parameters x and y of type int. You have rect area being declared, which is a method. It doesn't have an input parameter, it is returning an integer data type. And you have declared a second class called as rect area, which contains the main function. And inside the main function, you are creating two objects of the class rectangle. One is rect1, another is rect2. Now, the length and width are directly accessed in this step using the object rect1. So rect1.length is 15 and rect1.width is 10. So that the member variables are directly accessed using the object rect1. Then you are directly accessing these variables of rect1 length and rect1 width to calculate the area, which is just the multiplication of this. Instead, let's say in the case of the object rect2, I am not accessing length and width directly, but instead I am using this method get data to initialize the variable. So when I say get data of 20, 12, I am passing the value 20 to x, 12 to y. Inside I am copying the value of x to length and y to width. So length now will be 20, width now will be 12, and then I am using the next method rect area, calling that function will multiply the current length and width and return me the area. So the area 2 now will have the value of 20 into 12, which is 240. And this is a print statement. So area 1 and area 2, they are totally different because one is using rect1 object and area 2 is using rect2 objects. So area 1, which will be printed as 150, and area 2 will be printed as 240. So a class can also have something called as a constructor. So constructor is a special type of method which is used to initialize the object. If you had looked at the previous example, we had length and width as variables. So when you create an object, you need to know what should be the value of length and width. So either you can do it yourself by declaring a method, or while you create the object, you can initialize those variables. So that initialization can be done using a constructor. So every time an object is created using new keyword, at least one constructor is called. So if the programmer hasn't defined a constructor, then the compiler will provide you a constructor called as default constructor, and compiler will initialize those variables for you if the programmer hasn't written a constructor. But there are some rules for creating constructor. First and foremost, the constructor name must be same as its class name, and constructor must not have no explicit return type. So the name of the constructor, which is a method, which is a function, should be same as of class name, and the constructor should not return any values. A Java constructor cannot be abstract, static, final, or synchronous. So these are different keywords in Java that we will look as we go. So default constructor. So these are different types of constructor. First is default constructor. If you look at this inside the class, you can see that a constructor should have the same name of that of the class. So there is no such constructor being defined inside this class. There is only one method, which is display. So when you create this object, ideally it should go to the constructor and execute the constructor, but there is no constructor defined, because of which the compiler will provide you a constructor implicitly and initialize the variable id and name. So constructor is basically for initializing the variables inside the class. So since the programmer is not doing that, the compiler will initialize it. So compiler by default will initialize the value id to 0 and name to null. Now there is a parameterized constructor. A constructor which has a specific number of parameters is called as a parameterized constructor. This a programmer should explicitly define in the class. The parameterized constructor is to provide different values to distinct objects. However, you can provide the same value also. Let's take an example. So if you see this method student4, it has the name same as that of the class, and it is a method. It has input parameters I, which is an integer, n, which is a string. This is a constructor, and inside the constructor value of I is copied to the member variable ID, and value of n is copied to the member variable name, which is basically you have initialized the member variables. Now when is this initialization happens? When you execute this statement, when you say new student 4 of 111 comma current, the value 111 will be passed to I and current will be passed to n, which initializes ID and name. So using the object s1 will have a variable ID with value 111 and variable name with string current. Now when you're creating the object s2, you are again calling the constructor because you are passing this 2 I rn to n. So for s2 object, the value of the variable ID is 222 and the value of the name is rn. So that you have initialized. Now when you display it separately using two different objects, s1.display will give you ID as 111, name as current. s2.display will give you ID as 222 and name as rn. Next we go to method overloading. So we have seen what a method is. Method is basically a function which is defined inside the class. So overloading means you can define functions or define methods of the same name but with different number of input parameters or type of input parameters. So method overloading is used when objects are required to perform similar tasks but using different input parameters. So depending on the input parameters, you can define different methods but with the same name. So when we call a method in an object, Java matches the method name first, then number and type of parameters to decide which one of the definitions to execute. Method overloading is a form of polymorphism. Method overloading increases readability of the program. So we will see an example to understand it better. So there are two types of method overloading. First one is by changing the number of arguments. So if you see here, there's a class called as adder, and I have defined two methods but with the same name, add. That's a static method. We'll see what static method is. But the methods have two different number of arguments. So first method add has a and b, which is two arguments. Second method has a, b and c of type int but with 3 input arguments. So these two are called as method overloading because you have the same method name but different number of arguments. Forget about static because static doesn't cause anything in the method overloading. So static means that you can access these functions without an object, that's all. Now when I say adder.add 11,11, so when I call 11,11, that is with 2 arguments, the compiler knows that it should call this function, which is a plus b. Similarly, when I call add 11,11,11, the compiler knows that it should call the function with 3 input arguments, which is a, b, c. So in each of these two cases, compiler know, depending on the number of arguments, which of the overloaded functions to call, and it will call that functions. The functionality is same but the number of arguments are different. The next type of method overloading is called as by the data type change. So again the same example, but the input arguments for both overloaded add methods are same, number of input arguments are same, they differ in the type of data. So even if one of the arguments data type is different, the compiler will treat it as overloaded methods. So when I call add function with integer values 11,11, the first add method will be called because it takes input arguments of type int. And when I call add with decimal point numbers or floating numbers, the compiler knows that it needs to call the add method which accepts floating or a double point numbers, and so this method will be called. And the last one is static member. So we have seen static methods in our previous example. So let's see what the static is. So whenever an object of class is created, you know that there are separate memory locations being created for variables and method. That is good. But what if we don't want that? What if we say that whenever a new object is created, I should not use a new memory location? So there comes the static. When a variable or method is declared static, it is common to all objects. In other words, these variables and methods can be accessed using the class name and not by using an object. So any static member can be accessed directly by class name. You don't want to create an object for that static member, whether it is a static data member or static method. You can directly use the class name, and you can use dot, and you can access the member. Static members belong to the class as a whole rather than the objects. So let's see an example. You see that this two methods. So we have declared a class math operation. It has two methods, mul and divide. Both are static. There is a class math application which we have defined the main function, and main function call this method mul and divide. So the static method mul and divide has input arguments x and y, and they do the required functionality, return the value. When I want to call the multiplication functions, which is mul, you see that I haven't declared an object for math operation. Instead, I directly use the class name, which is math operation dot mul, and I pass the arguments which will eventually call this static function. So here, if you look at this, I haven't defined an object. Like I have been accessing this mul function without defining an object. I can directly use the class name. Similarly, for divide is a static function. I'm again using directly the class name math operation dot divide. I'm passing the value a comma 2.0. So again, this doesn't need a static function. This uses a static function. It doesn't need an object. So here are some questions on our lecture. You can go through the questions. It will help you in understanding the lecture. And there is a programming exercise, where the simple programming exercise where you can create a bank account, everything. And this is something where you can try it out. So already the code is given, but you need to modify this code to achieve a desired result. And there is one bug in this code. You can try to solve the bug. Okay. Thank you.